So today we're working on naming compounds with polyatomic ions. These follow some pretty simple rules, very similar to naming with transition metals, so naming type 2 binary ionic compounds, but instead this time the compounds will have at least 3 elements. Sometimes those elements get packed together or stuck together with their own charge. That's what we call a polyatomic ion. So to work with naming these compounds, it's important that you have a couple things handy. First is your polyatomic ion sheet. This is in the assignment for today if you didn't already download it. We'll be working with the the compounds that are listed over here on the right-hand side. The other thing you will need is the oxidation numbers for our common elements that we use frequently. So I just got this image by typing in oxidation number periodic table image, and this is an easy one to read, so this is the one I chose. You're welcome to use this screen, take a screenshot of it so you have it, and that'll give you the common oxidation numbers for elements that we use all the time. All right, so back to naming compounds with polyatomic ions. A polyatomic ion is something where the ion, meaning something that has a charge, is made of more than one element stuck together. These groups of atoms always stay together and they have a charge. Poly, if we break down the term, poly means many, atomic means atom, and ion means it has a charge. So this is a many atom compound with a charge. And I always call this the PAIL, the Polyatomic Ion List. You'll use this list to know what the charge is so you can learn how to name the compound that has this polyatomic ion in it. Polyatomic ions can combine with other elements to form neutral compounds. These neutral compounds, when we stick a polyatomic ion together with another element, they're called ternary ionic compounds. Ternary refers to 3. So these have at least 3 elements in them. To name these, the rules are fairly simple. List the ions with their charges. Follow your transition metal rules when you need to. And now it's time to practice. So our first polyatomic ion is NaNO3. So when we look at NaNO3, we have some things that we've worked with before and some things we haven't worked with before. So Na, we know, is sodium. Sodium, if I go over to our oxidation numbers, sodium has a +1 charge. It's over here in the first column. So sodium +1. NO3 is a polyatomic ion. So NO3 is always found together. And if we take a look at our polyatomic ion list and scroll down to find NO3, we can see that NO3 is called nitrate. It has a -1 charge. So NO3 is -1. When we combine these, we get sodium nitrate. CaSO4. Ca is calcium. Let's take a look at the charge for calcium. Calcium is in the second group, so it has a +2 charge. And SO4, let's find out what SO4 is. SO4 is sulfate. That is a -2 charge, so those two things balance out. So CaSO4 is calcium sulfate. CuSO3. Cu is copper. So here I know, right off the top of my head, copper is a transition metal. So I know that it's likely I'm going to need to have a Roman numeral in parentheses between the copper and the SO3. So let's take a look at the charges for each so we can figure out what Roman numeral I will need. Copper, we're not sure. That could be anything in the, it could be copper 2 or it could be copper 3. The polyatomic ion is SO3. Whoops. So let's find SO3 down here. SO3 is a -2, and it's called sulfite. So if SO3 is a -2, copper over here has to be a +2. So my compound name here is copper 2 sulfite. NH4 taken twice, O. So this is how you say this formula. NH4 is the polyatomic ion. You can see we have 2 of these NH4 ions, and we are matching them up with an oxygen. So if we take a look at our NH4, NH4 is ammonium. That has an oxidation number of +1. We have 2 of them, so that gives me a +2. When I compare this with oxygen, oxygen is a -2. So we don't need a Roman numeral here when we name them. We're going to call this ammonium oxide. So this one is different from the first two because in this case the polyatomic ion is taking the place of the metal. It's the positive ion. We use the regular naming system for the nonmetal ion by taking the root word and then adding IDE to the end. All right, let's look at our next one. LiCN. Cn is our polyatomic ion, and we're starting with lithium. Lithium is in our group 1, so it has a +1 charge. It's not a transition metal, which means we do not need any parentheses and Roman numerals. And Cn, let's take a look at our polyatomic ion. Cn is a -1 charge, and it is called cyanide. So the name for LiCN is lithium cyanide. FeOH taken 3 times. Notice this is not OH3. OH3 would mean that there are 3 hydrogens. But since this is in parentheses, it means there are 3 OHs. So it would really look like this. Well, there's your name for it. Let's go back for a second. And let me write out what this would look like. This would be iron, which is a transition metal. We're going to need some Roman numerals. And that iron is attached to 3 OHs. That's what the OH in parentheses taken 3 times means. So let's figure out our Roman numerals. You saw it just a minute ago, but let's figure it out anyway. So Fe, we're not sure what the Roman numeral on Fe is. It could be either 2 or it could be 3. We need to find OH and compare. OH is hydroxide. We have 3 of those, remember, so it's -1, -1, -1. So we have a -3, which means to balance that out, iron has to be iron 3. So we have iron 3 hydroxide. Just 2 more to practice with. We have NH4 taken twice and CO3. All right, so our NH4 is, go back, NH4 is ammonium. That's worth +1. +1 and +1 because remember it was taken twice, so we're up to a +2. And the other part of this compound is CO3. This is another polyatomic ion, so in this compound we have 2 polyatomic ions attached to each other. This is a -2. So that means we have ammonium carbonate. CO3 is carbonate, NH4 is ammonium. You can see that by having 2 ammoniums, we balance out the -2 carbonate charge. And our final ternary ionic compound is NiPO4. Ni is nickel. If we find nickel in our oxidation chart, it looks like nickel is going to fall into our transition metal area. So that means we are going to need a Roman numeral. We are combining nickel with PO4. PO4 is phosphate. They're -3. So if we look over here, how many nickels do we need to balance out with a -3? We need 3 nickels to balance out with the -3. So it's nickel 3 phosphate. In your next assignment, you'll be practicing this. If you have any questions, let me know.